Speaking of jumping over hurdles, let's talk about IRR, internal rate of return, a very popular method for looking at major capital investment projects. And what exactly is that decision rule? Well, it's in the light bulb. If your project IRR is greater than the hurdle rate or required rate of return in your company, again, you have to ask that of the CFO. We're going to accept the project. So does your project IRR jump over the hurdle? As soon as you see the letters IRR, you have to calculate it by trial and error. And you have to basically write down the words NPV equals 0 equals, and we'll go over that. If your project IRR is greater than the hurdle rate, the decision rule is accept the project. So you're looking to jump over the hurdle, and you have to figure out what that hurdle is by talking to the CFO. Here's an example. So when I see the letters, if you have to calculate the IRR, we have to basically put down the cash outflow and then the cash inflows, and then discount them back to today and see what rate, and say NPV equals 0 equals minus the first cash outflow plus the first cash inflow over 1 plus some rate, plus second cash inflow over 1 plus some rate squared, third cash inflow over 1 plus some rate to the fourth, and so on. And you start basically just plugging and chugging, creating yourself an NPV profile, plug in the rate by trial and error, 0%, then try 5%, and that still gives you a positive NPV, and then try 10%, that still gives you a positive NPV, and then somewhere between 10 and 15%, you cross through the x-axis, and NPV is equal to 0, and that rate is about 13.1%. So basically, you write down the words NPV equals 0 equals minus the first cash outflow plus the first cash inflow divided by 1 plus some rate plus second cash inflow over 1 plus some rate squared, third cash inflow over 1 plus some rate cubed, and so on, and find the rate at which your discounted cash inflows are equal to your cash outflow, and that is your IRR. And then if your IRR jumps over the hurdle, in this case, the company's hurdle rate is 18%. In this case, we don't take the investment because your project IRR is less than the required rate of return. Here's another example. And if the problem is find the IRR, you write the letters and words down, NPV equals 0 equals, and then proceed through the cash flow. So NPV equals 0 equals minus 435.44 plus 100 over 1 plus R plus 200 over 1 plus R squared plus 300 over 1 plus R cubed, and you solve for the rate at which those discounted cash inflows equal the cash outflow of 435.44. Again, create an NPV profile, guess at 0%, guess at 5%, 10%, 15%, 20%, and on up until you hit 0 on the left side of the equation. You can also, another good method is to type this, know the syntax for typing it into your financial calculator, and then also know the syntax of typing it into Excel. And if you do that, you'll be able to solve this very, very quickly. But you should understand the mathematics that are going on behind in those mathematical calculations. And there's the math right there on the screen. Calculate the IRR using a graphing calculator or Excel. Guess and check if there's not a calculator or Excel available. And you can see from this table that the NPV equals 0. That's called an NPV profile. You can see at that NPV profile table that the IRR is exactly at 15%. Again, you can do that by trial and error. You can do it by graphing calculator, or you can do that by using Excel, using the equal IRR function. If your project IRR 15% is higher than the company's hurdle rate, you accept. If your project is less than the company's hurdle rate or required rate of return, you will get rejected and you won't get your initial investment. In this case, if the required rate of return is 18%, again, this project is rejected. And here is a graphic of how to use both the graphing calculator to calculate the IRR, syntax for typing it into the calculator, and also using Excel.
Today, I'm going to be showing you how to calculate the internal rate of return using a TI-84 graphing calculator as well as Excel. For both of these examples, we are going to be using example 9.4 from the slideshow. But first, we're going to be focusing on solving with the graphing calculator. So our first step in solving one of these problems by hand and using a graphing calculator is to simply just list your givens. And that is exactly what I did there. Our second step is to create a timeline of events for us to better visualize what we are actually doing in this problem. So after our timeline is drawn, we can see that in the first year, our initial payment is $435.44. And then each year after that, we get a cash inflow of $100 in the first year, $200 in the second year, and $300 in the third year. The third step in solving one of these problems is to set our net present value equal to 0. After we set that equal to 0, we then plug in our project costs and our cash flows. We then have to plug in 100, 200, and 300 into our equation. However, when we plug in 100, 200, and 300 into our equation, we have to plug each value individually over top of 1 plus r, all raised to the power of whatever year that cash flow is in. So for example, in year 1, 100 would be divided by 1 plus r in parentheses raised to the first power. And in the second year, it would be 200 all over 1 plus r, all in parentheses, raised to the second power because it's in year 2. And once we have this equation set equal to 0, we can find r by plugging and chugging with our graphing calculator. All right, so now that we wrote out our equation and we understand the math that goes on behind the internal rate of return, we can now solve the problem using our TI-84 graphing calculator. And it's actually a lot easier than it sounds. So we just turn our graphing calculator on, go to our apps button, go to finance, which is number 1. And now we have a list of options that we can choose from, but we want to go to number 8, which says IRR. Click enter, and we are given IRR parentheses. So what we have to do is plug in our project cost first. You always plug in your cost first. Make sure you plug that in as a negative. So I'm going to type negative 435.44. Now you have to type in a comma before you list your projected cash flows. At bracket, which is second left parentheses. And now start typing in your year 1, year 2, and year 3 values. So our year 1 value is 100, comma, 200, comma, 300. End bracket and right parentheses. That closes up the formula and makes sure that it calculates once you hit enter. Now all you have to do is hit enter, and you should get your value to be 15.00001464. And that is how you calculate the internal rate of return on a TI-84 graphing calculator. So now jumping over to Excel, I'm going to show you how to calculate the internal rate of return using an Excel function. So the first thing that I did was I listed my givens in a vertical column because it makes it a lot easier to solve for the IRR once you organize all of your values. The next thing that I'm going to do is I'm just going to click on a random cell, type in equals IRR, left parentheses, hover over my values, select my values. In this case, it goes from B1 to B4, hit the right parentheses and hit enter. And we should get that our value for IRR is 15%. And we know that is right because we also calculated it on our TI-84 graphing calculator and also got the same value of 15%. And since 15% is less than 18%, we are going to be rejecting this project.
There's some problems with the IRR we can get into, and this is one of the reasons the NPV method is the best method. Some problems arise with the IRR when the cash flows are non-conventional. In other words, they go minus, plus, minus on the timeline. So minus 60 plus 155 minus 100. This will result in an unhappy CFO if you come in with cash flows that look like that. CFO likes to see minus, plus, plus, plus. But in the rare case where, let's say you need a chemical cleanup or something in the second year and there's a cash outflow, these are called non-conventional cash flows. You may get into multiple rates of return. If you write down NPV equals 0 equals minus 435.44 plus 155 over 1 plus some rate plus minus 100 over 1 plus some rate squared and try and solve that. You'll find multiple rates of return. There might be, according to Descartes' rule of sign, there might be no IRRs, but there might be a maximum of 2 because the signs change twice, from minus to plus, then plus to minus. And that's called René Descartes' rule of sign. The reaction from the CFO will be, yikes, I really don't like the look of these cash flows. So probably I would advise you never go into a CFO's office with non-conventional cash flows. It results in a curve that looks like this. In an MPV profile, you can see that the MPV is positive at 2 different rates, or zero, at 2 different rates, 25% and 33 1/3%, and the CFO is going to be totally confused as to what the real IRR is. So you want to avoid non-conventional cash flows. Use the MPV method as the best method for calculating large capital investment projects, and you won't get multiple rates of return, multiple IRRs. Here's another one, minus 51 plus 100 minus 50. Again, we can see, according to René Descartes' rule of sign, there are 2 possible IRRs maximum. There could be 1, there could be none. So it really depends on the math. Again, what do? You write down MPV equals 0 equals minus 51 plus 100 over 1 plus R plus minus 50 over 1 plus R squared. These are non-conventional cash flows not favored by the CFO, and you just might have several, or there might be none. So MPV equals 0 equals minus 51 plus 100 over 1 plus some rate plus minus 50 over 1 plus some rate squared. And we find that there are no IRRs for this one. This is a total failure. There are no IRRs in this case. As René Descartes' rule of sign tells you, there might be a max of 2, there might be 1, there might be none. In this case, there are no IRRs that solve that equation. So Descartes' rule of sign, follow it carefully. It says the maximum possible number of internal rates of return is equal to the number of times the signs change in the cash flows. And avoid non-conventional cash flows if you can. Some of the problems with the IRR, another is if we have mutually exclusive projects. If I accept Project X on the corner of College and Atherton, I can't take Project Y. I can't afford to put a McDonald's and a Chick-fil-A store both on that small corner. These are mutually exclusive projects. I only have so much money to pay for these. Which one is better? Again, the way to look at these, the best way is MPV versus IRR, but we'll do both. The possibility is when they're mutually exclusive, they might cross over. So we lay out the cash flows. Notice that they both cost $100,000 in investment. They have different cash inflows over the years. And if I do an IRR, this table says take Project A, build the McDonald's. It generates 24% internal rate of return, whereas the Chick-fil-A only generates 21% on that corner. But there's a problem with the IRRs because if you plot them and you plot the MPV profiles, you may see that these 2 projects cross over. At the lower rates of return, I take Project A, McDonald's, and at higher rates of return, I take Project B. Project B looks better, and they cross over at about 11%. And you can calculate that crossover rate by taking the MPV of B minus A. So take the cash flows in the prior chart and subtract A from B, take B minus A, and calculate the delta cash flows and then do the IRR on the difference. So like a third column. So here you can see at low rates, low discount rates, we invest in Project B, BBB, and then it crosses over to AAA. So it's, I had that wrong, it's Chick-fil-A, and then at higher discount rates, it's McDonald's, and it's crossing over at about 11%. So it's very confusing. Again, another one of the shortcomings of the internal rate of return. They might cross over. IRRs can be misleading. Watch your step. Proceed with caution. Don't rank mutually exclusive either or type projects based on their IRR. Look at them based on NPV. That's the best method. Here's another look at two different investments, and might these cross over? Are they mutually exclusive? Looks like they cost about the same amount of money. We could consider these mutually exclusive. And to calculate any possible crossover rate, I take investment B minus investment A, and watch your sign. Be very careful of the sign. So I take minus 500 minus a minus 400 to get minus 100, and then I take 320 minus 250 to get 70, and 340 minus 280 to get 60. And then I do the IRR on those on the third column, B minus A, to find the crossover rate. So NPV equals 0. Again, NPV of B minus A equals 0, and then do the IRR formula on the three cash flows, minus 100. So NPV equals 0 equals minus 100 plus 70 over 1 plus some rate, and 60 over 1 plus some rate squared. And I get a crossover rate of 20%. So we're indifferent at a 20% rate. That's where NPV equals 0. What are some advantages of IRR? Well, A, it's very popular. It's closely related to NPV, but sometimes gives you identical decisions, easy to answer and communicate. Some practical advantages over the NPV, because we like to talk about percentages. What's the percentage return on your project? But some of the disadvantages are when I have non-conventional cash flows, I might get multiple IRRs, or I might get no IRR with non-conventional cash flows, and it may lead to incorrect decisions when I'm looking at mutually exclusive investments, because we might have a crossover of the two projects. Modified IRR is a new method to look at some of the IRR issues. I can do discounting and discount that third negative number back to today, and actually come up with an IRR rather than avoiding the multiple answer dilemma. I can look at reinvesting the second cash flow, or I can do a combination of the two methods. And all three of these methods result in an excess of almost an 20% IRR. So modified IRR is a way of getting around some of the issues that are involved with internal rate of return.